Okay, so here's another classic mixture problem that comes up. It deals with percents, but again, remember we're talking about an x plus y equals a total, right? Our freebie, and then some strength, some ax plus by equals some other total, right? So this is how all mixture problems are set up, even when they're percents. So in this first one, we're talking about we want to put how much of 15% nickel alloy must be mixed with a 10% nickel alloy to create 40 grams of a 12% nickel solution. So again, what are our unknowns? Well, X would be the grams of 15% nickel, and Y would be the grams of 10% nickel. So we have a couple of mixtures that are relatively weak and strong. Together, we want to create a 12 nickel, I guess that should be alloy, not solution. So how do we do that? Well, again, there's a total of 40 grams. So grams of the 15%, right, this is grams, plus grams of the 10% should equal the total grams that I have all together. Right, so there's our freebie. What are we multiplying? Well, the amount of nickel, right, this is pure nickel if you would. So the pure nickel that I have would be 0.15 times x. Whatever this total is, 15% of it is actually nickel. Right, so remember the idea that a part is a percent of a total. And so how much nickel do we have? Well, it's 15%, 0.15, and we don't know how much of that 15% that we have. So classic case, but there's our strength. Plus, how strong was the other nickel mixture? It's 10%. So that means if I have Y amount, 10% of it is actually pure nickel. What about the final solution or the final alloy? Well, we know we have 40 grams, and only 12% of it is nickel. So that's basically 0.12 times 40. So this is a little similar to the last couple that we did, where one total was given, and then we had to actually do a multiplication to get the other total. But I do have, right, pure nickel plus pure nickel equals pure nickel. Two equations, two unknowns, we're done, right? That's classic percent mixture problem. So last but not least, a chemist needs to make 2 liters of a 15% acid solution. She has a 10% acid solution and a 35% acid solution. How many liters of each will she need to get her desired solution? Okay, so again, what are our unknowns? Well, X could be the amount of 10%, right, acid, and I guess that would be in liters, and Y would be the liters of 35% acid, right? And together we want a 15%, so we're probably going to need more of the 10 than we do the 35. So what's our equations? Well, let's talk about the total amount of liters that we have. I have an X amount of 10%. I'm going to add to it a Y amount of 35%. And what that equals is the total liters that I want when I'm done. All right, so that's a mixture of acid, probably water, whatever else. What's the strength equation? Well, this would be the pure acid. All right, so the final mixture, 2 liters, 15% is acid, so that's 0.15 times 2, whatever that number turns out to be. Again, we're using this idea that some part is a percent of a total. And so I have 2 total liters, 15% of it is acid, so what's the pure acid amount? 0.15 times T, part, right, percent times the total. So what about the pure acid coming from this amount? Well, 10% of it, right, is acid. What about this amount? 35% of it is acid. There's your strength equation. So 2 unknowns, 2 equations, we're set up, we're ready to solve. So hopefully you guys are seeing that rhythm. I think, again, we set up 7 different mixture problems, and you basically see that there's always a freebie, right? That's the easy one. And then the next one is what I playfully call a strength equation, and it usually involves some sort of a multiplication. How strong is X? How strong is Y? And we've set it equal to another total. Okay, so now what we're going to do is let's go backtrack and solve these guys using some of the methods that we know how.